All right, so welcome back. Now, still on isomerism, let's say we have a compound with double bond. And you know that I told you that when you see carbon, carbon double bond, that actually refers to, okay, what's this? So that actually refers to the alkene family, E and E. So the alkene families, they are the one that normally have carbon, carbon. So let's say in your let's say in the structure you actually have a double bond. So how do you, okay, well, let's look at isomerism now, of course, with a compound with double bond. So let's say you have butene. Let me still use that same boot, but this time butene, the one with double bond. So butene is C, from CN H2N. You remember the formula for butene family is CnH2n. Then if you put 4 here, because but actually means C4, C8. So if you put 4 for the value of n, what you are going to have is C4, C4H, 2 times 4 is 8. So C4H8. So how do you draw the structure of this guy? Very simple. You draw your C, your C, your C, then another C. Now you know that for a butene, since it is ENE, you must have at least one double bond. So put one double bond here at carbon 1. You can see that this double bond is attached to carbon. It's after carbon 1, right? So that double bond belongs to carbon 1. Then you now draw your hydrogen around the carbon. Now, since there is a double bond here, that's 1, 2, 3, 4 for this guy. 1, 2, 3, 4. Then for this guy also, 1, 2, 3, 4 like that. Then 1, 2, 3, 4. 1, 2, 3, 4. So that's how to draw that. Like that, like that, H, H, like that. So yeah, we are on the way now. Now if you look at this, this is 1, 2, 3, 4, that's C4. 1, 2, 3, 4, 5, 6, 7, 8, H8, which is actually correct because it's a double bond. Now you want to name this guy, since this double bond belongs to carbon 1, we have carbon 1, 2, 3, 4. Now since this double bond belongs to this guy, carbon 1, this double bond is, this is how you are checking double bond. This bond belongs to this bond belongs to this bond belongs to this bond. So because this one belongs to carbon 1, then if you want to name it, you can either see the name of this structure is 1 butene, 1 butene, but this is not a standard way, or you can write it in a standard way, but 1 in, showing that your double bond ENE is at carbon 1. But do you know that if you draw this structure in another way, your double bond might not fall on carbon 1, it might fall on carbon 2. And let's check that out. If you have C to C to C to C, that's C4. Then let's put our double bond here. That's on carbon 2. Then let's put our hydrogen. 1, 2, 3, 4. Then 1, 2, 3, 4. 1, 2, 3, 4. So this one is also balanced. Then this guy 1, 2, 3, 4. So this one is also balanced like that. Now if you want to name this guy, that would be carbon 1, carbon 2, carbon 3, carbon 4. I mean, yeah, that's carbon 1, carbon 2, carbon. So you see that this double bond falls on carbon 2 this time around. So if you want to name that one, you say that is but 2 in or 2 butene, whichever way, but this is more standard. That's between, and it is the same C4H8, just a difference in the position of this double bond. So because of that, we call these isomers, meaning they have the same chemical formula, the same molecular formula, but different structural formula, different structure of drawing them. So these are isomers, and this is called isomerism. Are you getting me? So that's what isomerism is all about. And this type of isomerism is what we call chain isomerism. This is called chain isomerism. So I'm going to be explaining stereoisomerism in the next video.